All right, 3D figures and volume. So I want to do a general overview real quick, and then I'm going to go over some of the key vocabulary that's the stuff that you just got to know, and the stuff that's going to kind of throw you off. So here are the two main things that your teacher is going to be trying to get you to understand. These are very complex ideas, and these formulas are easy if you know the parts to what you're looking at. So solve problems involving volume of rectangular prisms, rectangular pyramids, and triangular pyramids. So what I heard there was vocabulary, vocabulary, vocabulary. Um, solve problems involving the lateral and total surface area of a rectangular prism, rectangular pyramid, vocabulary, and vocabulary, vocabulary by determining the area of the shape's vocabulary. So there's a whole bunch of new vocabulary. There's three things that I want to review. The things that are in red are the things that you have got to know. The things that are in blue are like the things you probably already know, and they're not like super critical to you being successful or not. The stuff that's in purple is stuff you have to know. Like you will not make it if you don't know those three words. So let's do surface area. Went ahead and got volume set up for you. This is where it's going to look like on your formula chart. So a prism, area of the base, capital B means area of base of a three-dimensional figure. I'll help you define that, and that's not a big deal. A pyramid is going to be 1/3 the volume of a prism. Because if you think of a prism being a cube or just a box, and then you shave the sides off of it, like the corners off, you end up with a pyramid. The volume of a pyramid is approximately 1/3 that of a prism. So basically, it's also area of the base times height divided by 3. When you're dealing with thirds, it's always sketchy. So, surface area. To give you a very simple example of what surface area is and how it functions, the purpose behind it is to find out how much it takes to cover something. So like area is how much it can fit inside of a two-dimensional figure, and how perimeter is how far around a two-dimensional figure is. Well, surface area is how much does it take to cover it? How much surface is there? What's the area of every single side of a three-dimensional figure? And you might be saying, well, why do I need to know this? Need, I wouldn't say there's a need. Surface area in general is just what is the area of every side of the three-dimensional shape. Total surface area is going to be finding the area of each side and then adding them all together. The reason that there is the general term surface area is to describe what surface area is, and the reason it's differentiated between total and lateral is because one is all of it and one is only the sides. How do you define the base? Okay, so with prisms, all you have to do is choose the base. So, like, I went ahead and highlighted the base I wanted to choose in yellow. So you can see that the bases are always going to be parallel. Like, if you stacked up this side right here, and you looked through the box, you would look at the other end, and it would be right here. Same thing with this. Over here, you look through the box, and it's over here. That's the height of the prism, and that's also going to show you where the bases are. So if we wanted to find total surface area, we would be finding the area of this square, and 4 rectangles from the sides, the top, and the bottom of how this is laying down. So you can see the orientation is going to change how you say top, bottom. That's why the word base is a vocabulary word. So you can see where this box, imagine it's saying Amazon on the side. The thing where it's laying down, right here, the side where it's laying down, that's on, like, say, the table, that is going to be a side, along with this. This is also a side. We're going to also have the top as a side, and we can have this side over here. So there's going to be 4 of those. So think of prisms as 4 sides and 2 bases. The bases are going to be any pair of parallel sides. So, I mean, we can choose any two sides as the base. As long as they're parallel to each other, that will determine the height. Now, whenever we go to lateral surface area, think of only finding the area of those four sides and not the two bases. So think about wrapping a piece of paper around a Coke can. Although it's not a prism, it's a cylinder. The idea of not covering the top or the bottom, not having a label like on a Coke can, how it's silver on top and on the bottom, that would be an example of lateral surface area. How much does it take to cover the sides? A net would be, here's a net of a cube. Okay, we know that cubes have 6 sides. I mean, like, seriously, don't criticize me. All right, I'm drawing you a net of a cube. It is, nets are, I mean, and this takes many forms, and probably in class, whenever you go over nets, there can be how many forms of a net of a cube can you find? And, people can be like, I found 3, I found 5. There's a whole bunch, because you can just move the squares around. But it has 6. Basically, what a net is any three-dimensional figure unfolded. So this would be a pyramid net, a square pyramid. So if you were to take all 4 of these sides and then bring them up to the center point, and you're looking at the top of the pyramid, it turned back into a pyramid. And if you unfold it, it's called a net. So a net is a 2-dimensional representation of a 3-dimensional figure. It makes it a lot easier sometimes to look at a net and find the area of one triangle and one square versus using a formula and finding lateral height and all kinds of stuff. So we just went through prisms, but there's different types of prisms. What we looked at over here for surface area was this is also going to be kind of a nuance in naming prisms. Prisms are anything that are connected by one pair of parallel sides, and then all of the other sides are rectangles. Also know that a square can be a rectangle. So this is going to be a rectangular prism. So is this. But notice how the bases are connected by nothing but one rectangle, 2 rectangles, 3 rectangles, 4 rectangles. Okay. So you can see the same thing here. It's a square base that's connected together by 4 rectangles. That's what makes it a rectangular prism. And you can elongate the bases and make it look more like a rectangle, but either way, it's going to be a rectangular prism. Because if I wanted the bottom and the top to be bases, well then, going around it, like so, all of those shapes are still quadrilaterals. They're connected by quadrilaterals that have 2 pairs of parallel sides. Basically, it's either going to be a square or a rectangle. That point is emphasized on a triangular prism. So this is a triangle base. So when you identify the base, that's going to be what you name the prism. So this is a triangular prism because the bases are connected by 1, 2, 3 rectangles. This is also a triangular prism. The only difference is this is a right triangle. So what shape is the base? A right triangle. Capital B would be area of a right triangle, which is just base times height divided by 2. Same thing with this one. We call that an equilateral triangle. The way to tell the height of any prism is the distance from one base to the next. The way to tell the height of a base is where the right angle sits on the shape that is the base. So just like whenever we were dealing with 2-dimensional figures, it was the same thing. Wherever the right angle sits, that's going to be the height of a 2-dimensional figure. That changes a little bit with pyramids because the sides are slanted. So that's going to be called slant height, but that's going to come in later. So here is net again. I already showed you a net of a square pyramid. The base was a square. That's why I called it a square pyramid. It could be a triangular pyramid. It could be a rectangular pyramid. It could be a square pyramid. All of them are pyramids, but I'm defining what type of pyramid they are based on based on their base. Well, how do you base a base on its base? Well, go to hit a home run, go on all the bases. Quit saying base. So these are examples of these vocabulary words. The whole point of pyramids is the process is the exact same as a prism, but you just divide by 3. That is the most simple way that it could be done. When you're finding volume, surface area is always going to be finding the area of all the sides and adding them up. It's like the complicated way to do perimeter of a 3-dimensional figure. And that's about it. So the basics are there's going to be a height. There's also going to be a height. One of them is going to be for 3D. That's a P. 3D. And the other one's going to be for 2D. So the reason you already studied 2-dimensional figures was to understand what height looks like there. And the reason you're going to get into 3-dimensional figures is to understand what height looks like there. That's going to be from the base to the tallest point. That's always going to be defined, again, by the right angle. So the right angle will show you where the base is at. See, look, it's already got an arrow pointing at where the chair sits. The back of the chair is always going to show you how high it is. And if you want to also get crazy about it, and I know that you do, what letter does that make? It makes an H. Why? Because it means height. Yes, I know. So a whole bunch of information to take in. But the idea behind this video and sending this to you as a preview is to get your mind going about the type of vocabulary, associating those vocabulary with shapes, 3-dimensional ones. All right. So if you look at a box, don't call it a box. Call it a rectangular prism. Or you can call it a prism. And if it's a triangle box because I got a poster shipped to you and it's got triangles on both sides, it's connected by nothing but rectangles on the sides, then that would be a triangular prism. Prisms are everywhere. We base our lives on prisms. All right, so surface area covers stuff. Volume fills up 3-dimensional figures. Lateral surface area, how much does it cover without the bases on the sides? Always defining where the base is. You got to hit the base first. Find the base first and then locate the other base. That'll tell you the height of the prism. Height, how do you spell? I don't know. Prism. I'm going to put priz.